Hi everybody, it's Mrs. Garcia. Sorry I'm not here today, but I thought I'd make a little video to help with your lesson. Today we're covering the surface area of your cones. So I'd like you to be able to walk out the door today feeling comfortable finding the surface area of any cone that we give you today. So let's start to talk about your parts of your cone. There's two main things that I really want to emphasize here. One is your height. Your height always is going to be the height that starts at the actual vertex of the cone, and when you draw it, it's going to go straight down to the middle of your base such that it's perpendicular to that base. So again, notice how you've got that little right angle indicating that it's perpendicular. We typically use the variable h to denote your height. The other kind of height, though, is a little bit different. It's called your slant height. Your slant height is one in which still starts at the vertex, but it's drawn so that way it goes to the actual edge of your base. So notice how it's a little bit slanted, unlike your regular height, which is vertical. We typically denote the variable L to signify your slant height. Now notice how your cones do have a circular base just like your cylinders, so they do have a radius measurement as well. Notice how that when I drew the height, the slant height, and now the radius, I formed a right triangle. This is helpful because remember we have Pythagorean's theorem that we can use to solve for missing pieces in right triangles. So your radius squared plus your h squared is equal to your L squared. This is going to become very helpful to us a little bit later on when we have some pieces of information that are missing, so we can definitely use your Pythagorean's theorem to help. So let's talk about your formulas. Since the area of your base is circular, we can use your area formula, which is your pi radius squared. Now your lateral area is going to be a little bit different than when we did it with your cylinders. Reason being is because you only have one base here, so that's going to alter how much lateral area we have. So because we only have one base, we're actually going to take half of your circumference. But instead of actually using the height or the h value, instead we're going to use your slant height, because the slant height is actually what's on the lateral face of your cone. Now for your surface area, since we only have one base, we're only going to add one base to your lateral area. So here are your formulas. We want to make sure to put those on your formula sheet. So the area of your base is your pi radius squared. Your lateral area is half of your circumference times your slant height. And surface area is your lateral area plus one of your bases. Okay, let's try some examples. Here's the first one. Now with every picture that you have, I would highly encourage you to label what information that you have in the picture. So for example, for this one, your radius is 5 meters and the 10 meters is for the slant height. Notice how it's on the outside edge of your cone, not on the inside, so that's indicating that it's your L or your slant height. So again, the area of your base, we're using your formula, which is your pi radius squared. So using the 5 meters, you'd have pi 5 squared, which simplifies to 25 pi. And again, don't forget your units. These are still meters squared. Okay, let's do your lateral area next. So keeping in mind your formula, it's half of your circumference times your slant height. Let's recall what we can do for your circumference. Your circumference formula is your 2 pi r, so 2 times pi times our radius, which is 5, and that simplifies down to 10 pi. So substituting in the 10 pi into your formula, we have 1/2 10 pi, and then times 10, which is your slant height. So again, that continues to simplify down to 50 pi meters squared. 1/2 times 10 is giving you 50, and again, we're leaving these answers exact, so we're leaving them in terms of pi. Again, once you have those two pieces, it's just a matter of putting them together for your surface area. So your surface area is your lateral area plus one of your bases. So you have 50 pi plus your 25 pi to give you a grand total of 75 pi meters squared. Now the nice thing with this question was we were given everything that we needed in order to fill into the formulas. But as we know, not all the questions are going to be quite that easy. So let's try another one. So again, with every picture that you have, label what information that you're given. So for this cone, the 10 kilometers is your radius, and the 24 kilometers is your height. Notice how it's the height inside the cone, so that's your h value, from the vertex perpendicular to your base. So breaking it down to your pieces, let's start with your base area first. So again, we're still using your formula, pi radius squared. So that's pi 10 squared, which simplifies to 100 pi kilometers squared. Now, your lateral area formula, remember, is your 1/2 circumference times your slant height. So we're taking your 1/2, keeping in mind we need to calculate your circumference. So that's your 2 pi r. So 2 pi times 10 simplifies to 20 pi. So we can substitute that into your formula. So you have the 1/2 times 20 pi. But now be careful. You're given the height, the h. You need the slant height, or the L, for your lateral area. So again, remember what we talked about with that radius, your height, and your slant height making a right triangle? You have 2 out of your 3 sides for that triangle, so you guessed it, we can use your Pythagorean's theorem to help find it. So you have r squared plus h squared equals L squared. So substituting in your values, your radius is 10 squared, plus your height of 24 squared equals your L squared. 10 squared plus 24 squared is 676, which is your L squared. But again, we need just the L, so we have to square root both sides. So square rooting 676 is giving us 26 for your slant height. So now we can simplify. So we have 1/2 times 20 pi times 26, which is giving us a total of 260 pi kilometers squared. So again, once you have these two pieces, it's just a matter of putting them together for your surface area. So it's your lateral area plus 1 base. Lateral area was 260 pi. Your base was 100 pi, so that's giving you a grand total of 360 pi kilometers squared. So really, you just need to make sure that you're careful with each question as far as what you're given. Are you given a radius or a diameter? Are you given a height or a slant height? And again, make sure that you're looking at the formulas as far as what you need to put in. If you have to find anything, Pythagorean's theorem is going to be very useful for you today. So keep in mind what's making your right triangles. Hopefully that helped. If you have any more questions, I'm sure your sub will be able to help answer a few of them, or we'll be able to talk more about them tomorrow. And again, make sure that you're showing your work on your homework, and we'll see you tomorrow.